Morning students, for today, let's see questions in miscellaneous exercise on chapter 2. Chapter 2, they are miscellaneous exercise na saying as First question is question number 3. Find the domain of the function. The given function fx is equal to x squared plus 2x plus 1 divided by x squared minus 8x plus 12. Function ampere. Function sigi domain putokadabukwa. Question number 3. Here fx is x squared plus 2x plus 1 divided by x squared minus 8x plus 12. Then numerator can be expressed as x plus 1 whole square, and this denominator x squared minus 8x plus 12 is a quadratic question in x. Then we can find, or we can factorize this quadratic question by using splitting method. For this, we need to find two numbers whose product is 12 and their sum is equal to minus 8. So the two numbers are minus 6x and minus 2. Number ani ki product se 12 taba. Number ani do koina plus tauragadi minus laadi number ani do negative oreko. And so this 8x can be expressed as minus 6x minus 2x. Middle term se split taure. To the first ka second ka term se again x se common log to we get x minus 6. Aduga segi third ka segi fourth suba term sidagi minus 2 common log to the x minus 6 pangeko. And x minus 6 is common to first term and second term. By taking x minus 6 common from first term and second term, we get x minus 2. And so this fx can be expressed as x plus 1 whole square divided by x minus 6 into x minus 2. It's the denominator have a function say x minus 6 into x minus 2 neba. Sigi value se karam kanda 0 satli haradi x in a 2 or kanda x in a kya or kanda 6 or kanda 0 satli kwa. Denominator 0 or the fx a real number or over here. Fx is always a real number for any x belongs to R. For any x belongs to R means for any values of x where x is a real number except x is equal to 2 and 6. If x is equal to 2, fx is not a real number. If x is equal to 6, fx is not a real number. Adudi 2 have a 6 have a image pangaruibako under the given function. Fx is equal to x plus 1 whole square divided by x minus 6 into x minus 2. Sigi function sida 2 siga 6 siga nangi image pangwedabanina mase domain da yaube adre domain da yauraga leitaradi nangi relation se function am tararoiba. Function oige haitardi every element of the domain has one and only one image oigadamneuko, which implies that fx is defined for all x belongs to R but x not equal to 2 and x not equal to 6 that defined Taudreko. And so the domain of the function will be equal to set of real number minus the set containing two elements 2 and 6. Nangi real number mayam leibasigi manungda kana logthokrani haiba 2 ga 6 ka logthokrani. 2 ga 6 ka logthokragadi nangi fx haiba function sigi image lo indaigani. 2 ga 6 ka hapagadi 2 gi image pangaroi 6 gi image pangaroi ko. Duna function sigi nangi image function se relation amani sigi fx se function amo oiba yararoiba. Function amo ohenge haitardi nangi domain se kai oigadaba set of real numbers tagi karamba set kaidokani 2 ga 6 ka yauba set se lagthokrani. Sina question number 3 gi ko. Now question number 4. Find the domain and range of the real function f defined by fx is equal to modulus of x minus 1. Nangi fx e modulus of x minus 1 haibam pireko. Segi domain ga kaiga putokadaba here. We have to determine the domain and range of the given function fx. First write the nature of the function. Here fx is equal to root over x minus 1. Root over x minus 1 se karam kanda khaktang real number oy. X minus 1 root over x minus 1 is a real number only when x minus 1. The expression under this square root is greater than or equal to 0. Positive oiba natraga 0 tara kanda khaktang nangi root over x minus 1 gi value se real number phangniba. Here fx is always a real number only when x minus 1 is greater than or equal to 0, which implies that modulus of x minus 1 se karam kanda define tawni only when x minus 1 is greater than or equal to kay oirakanda 0 oirakanda ko. Then adding plus 1 on both sides of the inequality, we have x should be greater than or equal to 1. Nangi x minus 1 na 0 taba natraga positive oige haitaradi x ki condition je 1 taba natraga 1 dagi chawba any real number am oigatabneba. And so domain of the function will be x. X belongs to R, but x should be greater than or equal to 1. In interval, it can be expressed as interval से 1, infinity the set kaniko. X is greater than or equal to 1 is represented by this ray, starting from plus 1 and goes to the right side of the inequality, right side of the number line. Number line se gi right side the set kaniba. Habadi 1 dagi horaga right side the set kadabani 1 se nang manaba yabra yai ko. When x is equal to 1, do the fx is 0 sali. Root over 0 di 0 tare ko. 0 se real number am oiri. Duna nangi domain se 1 dagina infinity bawgi marakta leba means any real number which is greater than or equal to 1. 1 dagi hena chawba real number mayam do the image pangani. 1 dagi hanthaba mayam do the image pangaroi ko. Sina domain pire. Then we need to find the condition of fx. X ki condition sina domain pigani. Aduga fx ki condition sina range piduni ko. Here fx is equal to modulus of x minus 1. Let x belongs to the domain. Domain is the interval 1, infinity sinibo ko. If x is equal to 1, nangi kwaitagi pikpa value sa x is equal to 1 then find the value of x minus 1. 1 minus 1 is 0 and f of x is equal to root over 0. Root over 0 is 0. Nangi x in a 1 taragadi nangi fx is 0 saleba. If x is equal to any real number and this a is greater than kanadai chawba number am already. 1 dagi chawba number am oy taragadi f of x f of a har ko root over a minus 1. A is always greater than kanadai chawba number am phangani greater than 0 neba. X in a 1 oirakanda di nangi fx ki value se 0 sale. X in any real number a oiraba and a is greater than 1. 1 dagi chawba number am oitaragadi nangi fx se kai dagi chawba hele which is greater than 0 ni ko. By combining these two cases, and we have this fx is greater than or equal to 0 for all x belongs to the interval 1, infinity. Nangi fx ki condition ja 0 dagi chawba natraga 0 ga manabo imphange ko. And hence the range of the function will be the set of real number x, but x should be greater than or equal to 0. Nangi x se real number amani aduga 0 dagi chawba natraga 0 dagi henba real number neba. In interval, it can be expressed as 0, infinity. 0 dagi hauraga real number mayam legre ko positive real number mayam do nangi range eba function se de yaurani. Now let's come to question number 5. Question number 5 is find the domain and range of the real function f defined by fx is equal to modulus of x minus 1. fx is modulus of x minus 1 haiba mapire ko. Sige domain ga kai ga puthokadaba, range ga puthokadaba. Domain haitar di kai na condition of x. X is image laiba, image laitaba ina khaido ani. Aduga condition of fx is na range biduini. For any x belongs to R, modulus of x minus 1 is always a positive real number. Any number amada modulus low by positive tani buka, which implies that fx is defined for all x belongs to R. Mana minter se kaino sigi x din nang any real number sin bakanda nangi fx modulus of x minus 1 have a real number adum tani have the real number amase real number amada map tawraga leiram gani baduna fx is defined for all x belongs to R. Therefore, the domain of the function will be equal to set of real number means every real number has its image under the function fx is equal to modulus of x minus 1. X is the any real number sin bakanda nangi modulus of x minus 1 se real number adum taba maramna nangi domain se set of real numbers tare ko. Now we are going to find range of the function. Range of the function is given by the condition of kaina pirakani fx na biduini ko. Then for any x belongs to R, x belongs to R din nangi domain se set of real numbers tare ko. Modulus of x minus 1 is always a positive real number, that is, this fx is greater than 0. Nangi x minus 1 sina positive adum tadoini na fx e kanadai chawbo ere 0. In particular, if x is equal to 1, particular and x e 1 loraba. fx modulus of x minus 1, 1 minus 1, which is equal to 0. By combining above these two cases, nangi case ani se combine tarakanda nang assign x in any real number ba aman x na kya taba 1 lore na losile ko adudi nangi fx se kayo na pange this fx is greater than or equal to 0 for all x belongs to R. See the particular case ni ko any x se 1 tai hena losile taragadi nangi si the p modulus of x minus 1 is 0 tarakya bagi case le bago. This fx is greater than or equal to 0 for all x belongs to R. So the range of the function fx will be x. X belongs to set of real numbers and x is greater than or equal to 0. As interval, it can be expressed as set of real number lying between 0, infinity. Habadi 0 yawba yaba aduga 0 dagi chawba real number mayam do oire ko. Sina range pire mathaki sina kai tare domain pire ko. Now question number 6. Let f be a function. Mase combine define the x, x square by 1 plus x square for all x belongs to R. Be a function from set of real numbers 2 into R. Determine the range of the function f. Nangi range puto o hai buka. Jadi kasi yang ase. Nangi function se combine define the fx is equal to x square divided by 1 plus x square. X saiba element ama se kanada method x square by 1 plus x square ne. This is the nature of the given function f defined from set of real numbers to set of real numbers and for all x belongs to R. Segi x se kaidagi logane element of the domain de logdunika. For any x belongs to R, x square is always greater than or equal to 0. Nangi x in any real number am oiba matamda any real number the square lobase 0 tagani natraga 0 dai chawba number in phangani and 1 plus x square is always greater than kanada gi chawba dum hengani x square dai x square the 1 am hapsiladi 1 plus x square is always greater than x square si dum chumaba statement amani ko and fx se kaina pi fx is given by x square divided by 1 plus x square. Denominator ga numerator ga denominator na sawa hentaragadi its quotient is always less than 1. 1 day less ko. Since 1 plus x square is greater than x square, so division of x square by 1 plus x square is always less than 1. Kanadagi less oigrani 1 dagi less si condition se phangi comments fx se kanana sawa helani heba. fx se 1 chawba helani for any real number khuding makta ko. In particular oina nang se kai gi case pangani. Particular the if x is equal to kya ga manaraba x is equal to 0 oitaragadi fx will be equal to 0 square divided by 1 plus 0 square. 0 by 1 is equal to 0. Nanga particular and x ki value the 0 ne na losilam taragadi nangi fx se kya fange 0 fange ko aduga x in a 0 na tab any real number amo oiba matam dadi nangi fx se always kanada gi less oi 1 dagi less oi na fangi ko dadi by combining these two results ahan bagi result to ga ani sube result se combine ta ubakanda nangi fx se kanagi marakta leire fx is bounded above by 1 and the bounded below by 0. fx se mathak ta na 1 na bound tore makha da na 0 na bound tore ko for all x belongs to R. X belongs to R habadi ma 0 ta be positive oi be negative oi be ba. Positive ka negative ka case tadi fx se 1 na bound tawe mathak ta ko particular and x in a 0 oiramagadi nangi fx se kanaga manabe 0 ga manabe duga 0 dagi tathabada di yaro duga 1 dagi lankhat pasu yaro ko aduna nangi fx se kanagi manung da leire 0 ga 1 ga gi marak da leire. Therefore the range of the function will be equal to x. X belongs to set of real number and x lying in between 0, 1. 0 city close ne 1 city open ni ko and then 0 close tare 1 half open and half close oirani nangi range se 0 ga 1 ga gi marak da leiba set of real numbers to adu gi marak da tarani. Next question number 8. Question number 8 ta kai hare let f containing order pairs 1, 1, 2, 3, 0, -1, -1, -3 be a function from z to z defined by fx is equal to ax plus b for some integers a and b. Then determine a and b. Nangon the function of period here. F is a function defined from set of integers to set of integers defined by fx is equal to ax plus b. Nangi nature of the function se kamina p ax plus b the period for some integers a and b and x belongs to z. Sigi x is always domain they out doing and there are 4 other pairs belonging to the function f. Function f se the yawa other pairs mari pire. They are other pair 1, 1, 2, 3, 0, -1 and -1, -3. So main tarago other pair mari pire. Then determine the values of kanagi value determine the haiba a ga b ga kwa. That we can choose any 2 other pairs belonging to this f. So first choose other pair 1, 1. Other pair 1, 1 belongs to f, which implies that 1, 1 implies that 1 is mapping to 1. First component z, second component na map rini. It can be expressed as f of 1 is equal to 1. Since this fx is defined as ax plus b, f of 1 is equal to 1 means f of 1. Find the value of f of 1 in this equation. Equation sidagi nang f of 1 putokane ba. Kamay putokane by putting x is equal to 1 in this equation. X की value से 1 since then a into 1 plus b will be equal to 1. So a plus b equals to 1. Right, equation number 1. Sige equation से solve tawada akhona equation 1 thabe and also the other pair 2, 3 belongs to the function f, which implies that f of 2 is equal to 3. F of 2 is equal to 3 means this 2 is mapping to the element 3. 2 se another map tawi 3 the map tawi which implies that 2 a into 2, putting the value of x is equal to 2 in this function, we have a into 2 plus b equals to 3. 2 times of a plus b is equal to 3. Write equation number 2. Solving equation 1 and equation number 2, find the values of a and b. 1 ga 2 ga solve tawraga nangna a ga b ga value hot kadamni ko. Now subtracting equation number 1 from equation number 2. Equation 1 se 2 dagi subtract tawrase, subtract left hand side and left hand side and right hand side and right hand side. Left, right, subtract our 2 times of a plus b minus a plus b equals to 3 minus 1. 2 times of a plus b, open this bracket, minus a minus b, 3 minus 1 is equal to plus 2. 2 times of a minus a plus b minus b is equal to 0 and 2. And so value of a is equal to 2. And a ki value here we get the value of a which is equal to 2. Putting the value of this a in equation number 1. The value of b is equal to minus 1. Therefore, a is equal to 2 and b is equal to minus 1. So, main tawraga nang na a ga b ga ki value hot pa mamay ko. Next question, question number 11. Let f be the subset of z cross z, defined by f is equal to other pair a into b comma a plus b. For all a and b belongs to z. Is f a function from z to z? Justify your answer. Nangonda sida f have a p. F is a relation niko. Define on z. Define on z means Cartesian product of z cross z. Nika na define the way product of any two integer is mapping to its sum. Nangonda integer ani logo kudingi. Integer ani dugi product to kanada map tawe heba magi sum da map tawe bako. Sida period f sa nang relation namani is f is a function. Sida period f sa function nam oibra hangako. Justify your answer. Question number 11. A relation f defined on z. A relation f defined on z is defined by command defined the way f is equal to a into b comma a plus b. For all a and b belongs to z. Sige f sa relation namani z the defined the way command defined the way the product of any two integer is mapping to its sum. Sige sa function oibra oidabra check torasiko. For any a and b belongs to z. For any two integers, we know that a into b is always an integer and also a plus b is always an integer. Integer ani lower the integer ani ki product se integer tani. Integer ani se ki plus adum integer tani ko. And so For every two integers a and b, a into b is mapping to kanada map tauramani, a plus b the map taurani ko under the relation f, but it is not a function. Function amadi oidreba mas relation oragasu maram kaigino haitaragadi nang element ani laurasi ko 2 ga kanaga laure 0 ga 2 into 0 is mapping to 2 plus 0, and 3 into 0 is mapping to 3 plus 0 belongs to f. F the loin yaugani maramdi kaigina product of integers to nang integer tani, sum of integers to integer tani ko. Si solve taurasi 2 into 0 is 0 and 2 plus 1 is equal to 0. 3 into 0 is 0 and the 3 in 3 plus 0 is equal to 3. See the 0 0 se order pair 0, 2, 0, 3 se f the yaure ko. But sigi 0 0 se image kya laire ani lai ko function the image ani lai biabra yade ko. It can be seen that the same first element, that is 0, has two different images, that is 2 and 3. Nangi first element 0 0 sa image ani laire function the image ani lai biabra yade ko. Then hence it is not a function. Steppy relation f sa function we biadre maram de kaigino 0 natros any atopa element laura check the way ko 0 se magi image kya phange ani phange ko nangi relation f se function nam oidre. Last question number 12. Let a containing 5 elements 9 10 11 12 and 13 and let f be a function defined from set a to set n. N means set of natural numbers niko. Be defined by fn is equal to the highest prime factor of n. Find the range of f. Nangi fn se kanada map tawi the highest prime factor of n. N have a natural number dugi khwaidagi sauba highest prime factor niko. Then find the range of f. Range puthosiko. Here set A having 5 elements. They are 9, 10, 11, 12 and 13, and f is a function defined from A to n defined by elements of A domain se silai ko. Fn is equal to the highest prime factor of n. First find f of 9. F of 9 A gi elements 9, 10, 11, 12, 13 oibanina we have to find the image of 9, 10, 11, 12 and the 13 niko. F of 9 sigi magi prime factor se kanano 9 the divide to we have factor sing se 1 factor sing se ko 1 3 9 sineba mongona divide to where se sta khwaidagi sawa prime number khalo hai tar di 3 se ta doini ko. F of 10 the divide to we have 10 the divide to we have factors sing se kaina factors of 10 are 1 2 5 10 si oidine ba sta khwaidagi sawa prime number hai taragadi 2 ga 5 ka se prime number ni, but 5 is the highest one, and so f of 10 will be equal to 5 tarega. Next f of 11. F of 11 is equal to 11. 11 hai se prime number amani aduna ma se prime number adum oisare. F of 12. 12 the divide to we have a factor say 1 2 3 4 6 and 12 niko. Adugi manung dagi khwaidagi sawu se kana ore 3 ore ko. F of 13, since 13 is a prime number, so f of 13 will be equal to 13. 13 is the highest prime factor of n. Here n is equal to 13. Therefore range of f, range ID kai haigi, range is the set formed by the images of elements of the domain hai given image. Nasai image kana form togre ahanba the image 3 ama yaure ko. 3 ama yaure, 5 ama yaure, 11 ama yaure, 3 ama 13 yaure. Therefore range of the function f will be 3 5 11 and 13. 3 repeat the ko amuktang khatang iran. For today let's end here.